Hello, folks. Welcome to Rational Science, directly from Germany, Frankfurt, Germany. We're going to have a question and answer at the end of the lecture, but today I think I'm going to be skipping the extinction part because there's really no news out there. Okay, I mean, COVID is over, right? And the war in Ukraine is over. And right now they have is just, this bombing of cities and more sanctions and counter sanctions. We just have to wait what happens with all of that. Instead, I'm going to get directly into something that happened this week. A fellow made a video of my science series, and he addressed each one of the videos, each one of the points, and I commend him for that. He went in there and analyzed each point from his point of view, obviously, right? And I think more people should be doing that, not necessarily with me, but with their teachers. I mean, if you have instructors or teachers in college or school or high school or whatever, I think you should put them on the spot, see how much they know, if they can defend their positions. Okay, and that's, I think, good for morale in science. You need that. Okay, anyways, he addressed almost every point. I think he addressed them all, in fact. And one of the issues there is that, he said that he's not a scientist or that he's not a physicist, okay? And we don't hold that against him here. I mean, under no circumstance. We don't care if he's got a PhD or he's just got a high school. We don't care, okay? We're going to look at his arguments, okay? That's important here, at least. And so we don't care if he's got a Nobel Prize or he just came out of school. That's one issue. The other one is that, since he addressed each one of the issues that I raised in my videos, there's no way I can have one lecture with all that, to address each one of those points. So I'm going to be doing that over the next few weeks. I was going to be addressing those same topics in one way or another in the next few weeks anyways, because that's why I was making the science series, okay? So in a way, it comes in very handy to use his video as a guide. And one of the issues there is that this fellow represents, as far as I'm concerned. I mean, I've been in this for 25 years now, and I've heard it all. Okay, and I can tell you one thing: this fellow has the same idea that 99% of the people out there have. And what I call misconceptions of science, misconceptions of physics. And those I want to address. But it's good because he's the typical case for what people usually think out there, what people say out there. So he's a perfect case for this. Anyways, the issues I'll be addressing in the coming weeks, okay, I want you to put it in the right context so that you're aware, those who want to follow the series, okay? And I'm going to be looking at what is science about, what is physics about, okay? I'm going to compare the scientific method versus what I call the mathematical method, okay? What's the mathematical method? It's what we have today and that we've had now for 400 years. Okay, that's essentially what I'm going to call the mathematical method. Why do I call it mathematical? Because they do everything by magic, black magic. What is black magic? When you move concepts around, you transfer energy, you wave the wave, you vibrate the field, and there are no such physical objects in physics. Okay, so we're going to distinguish objects from concepts, as you can see there at the bottom. We need to know what a difference is between an object and a concept. And that's 90% of the problem there, as I like to say. The definition of the word object destroys all religions. And I'm going to look at explain versus describe, another big major problem. People don't understand the difference between an explanation and a description. A lot of people think that an explanation is just a bunch of descriptions, a series of descriptions. Okay, big difference between an explanation and a description, but few people can tell them apart. And so we need to clarify that one. Theory versus hypothesis, big issue there also. People don't understand the difference. The establishment has brainwashed everyone to think that a hypothesis is an unproven theory, a tentative explanation. No, that's not what a hypothesis is at all. Okay, we're going to address that. And then we're going to look at rational versus irrational because everybody wants to think of themselves as rational. And we're going to show that no, we define what rational is, what irrational is, and then whoever meets those criteria is either rational or irrational. Okay, so we go by definitions. And so, what are we going to be addressing specifically? Well, here you have it. These are the invisible, intangible mechanisms, objects, things out there that the mathematical establishment has never been able to address, never been able to answer. Okay, and so they invoke gravity. You know, nobody can understand in mathematical physics, right? Nobody can understand what causes gravity, how it's caused, how Mother Nature does it. They can tell you how it does, how it moves, like the acceleration, that sort of thing. But they can't tell you the cause. How does Mother Nature perform this magic trick? That's what they cannot explain. So the mechanisms, that's what we're looking at. Magnetism, how does a magnet attract another? They don't have an explanation for that. People think they have, but again, they confuse description with explanation. And electricity, they have no idea how electricity works, mainly because they don't know what an atom looks like, which is the next one there, atomic architecture, behavior. They have this little bead rolling around the nucleus, and the only answer they have to give there is why doesn't the electron fly out of the atom? Like, why doesn't the Earth fly out of the solar system? Same thing here. If the electron is a little bead that goes around or is somewhere around the proton, the question there is, why doesn't it spontaneously fly away or fall into the nucleus? And if you cannot explain that, you do not have an explanation for electricity, because electricity today is defined as the flow of electron beads. So we have a problem with electricity if the atom that they're basing it on is bunk. Okay, and then light, of course, you need to understand what physical entity mediates light. And why are these important, invisible and intangible? Because we figured out pretty much, all the visible stuff. You ask a kid, how did the cart move from A to B? Okay, and he says, very simple. I attached the cart to a horse, and the horse pulled it, and that's how it went from A to B. And we all look at that, if he shows us a movie of that, right, or even with his explanation, and we all understand it. We understand it why? Because we see all the objects. Okay, we see everything there in front of us. We see the cart, we see the reins, we see the horse, and we see it moving. We see the movie of that, and we all understand it just by looking. You don't need to go to the university. You do not need to understand mathematics. All you need to understand is how that cart moved from A to B, and a 10-year-old can tell you that. Okay? And so what's the issue? The issue is that, all these invisible, intangible entities, what's the problem there, or mechanisms or phenomena? The problem there is you cannot see the mediator. That's the whole problem. Here you have the pen, okay? We let go of it, it falls to the floor, right? And you don't see anything here. You don't see anything here. You can't touch anything here or there. So people conclude that there's nothing there. Gravity is done by magic. And we're going to say the argument is going to be that there is something there. You just can't see it or touch it, but there is something there that is in contact with the skin of the pen. And people say, Bill, you're crazy. What do you mean there? I don't see anything. I don't touch it yet, because you're using see touch. The definition of the word object, that which has shape. So what's there, what's here or here, has shape, but you can't see or touch it. And you say, what kind of shape does it have? I can't see or touch it. Well, shape is unrelated to see and touch. That's the issue. Anyways, I'm going to get into that later on in the coming weeks. But the point here is, and if you're going to be doing gravity, if you're going to be doing light, if you're going to be doing electricity, magnetism, without a mediator, you're using black magic. And that's what mathematical physics has. That's why we call it mathemagical physics. They do it with black magic. They do it with concepts, not with objects. Okay, so that's the issue. Okay, so here we have a rundown of what mathematical method is, which is the one that I'm going to be addressing, attacking, okay, analyzing. Okay, and essentially the big problem is that this is not a scientific method. What this is just a method of research and persuasion and to give people something to do, to study as they call it. And studying is not science. Science is explaining us, telling me something that came out of all that work. If nothing comes out of that work, you're not doing science. And so what these people do is just, the so-called method that we inherited from the 17th century, so-called scientific, that's with quotations, right? Scientific revolution is this, it consists of you observe something or someone observes something, right? You give it a tentative explanation known as a hypothesis. And that's really not true because mathematical physics doesn't rely on explanations at all. As I showed in other videos, you have these people saying that science doesn't explain, meaning mathematics doesn't explain. Mathematics describes. So no, they don't do explanations, but they call them explanations because, again, people think that explanations are just a series of descriptions. Okay, but that's what they call a hypothesis, a tentative explanation. Okay, then they do a prediction. They say, okay, let me figure out and see if I understood if my theory or my tentative theory is correct, and I'm going to make a prediction to see if that's what happens when I put it under certain conditions. And then you do an experiment, meaning you're going to do some measurement. You describe it mathematically after you take some data and some numbers there, and then you describe it mathematically, perhaps with an equation. So that's just a description. So far you haven't explained anything, okay? They invent technology, and they think that technology is proof of theories. You'll hear a lot of people out there just parrot and say it over and over again because they never even thought what they're saying about what they're saying. And they say GPS proves that general relativity is correct, and computers prove that quantum mechanics is correct. Because you wouldn't have a computer, it wouldn't work if it weren't for quantum mechanics and blah, 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 blah. And again, it shows the irrationality of all these people. Okay? Does GPS prove that time is a physical object? That you can warp, that you can bend like a banana? Does a computer prove that a particle can be at two places at once? Because those are the explanations they give you. And you say, well, if that weren't true, the computer wouldn't work. The computer works because of trial and error. That's how technology is made. Or like Mr. Thomas Edison said, I haven't failed. I just found 10,000 ways that don't work. He just tried one thing after another until he got it right. Did Edison need to know what a field is or what electricity is? Obviously not in the 19th century. All he did was try things until he got it right. That's how technology works. It has nothing at all to do with the explanation, the theory of how it works out there in the invisible world of Mother Nature, Father Universe, or whoever. Okay, so this is the issue. And so people think that technology has something to do with science. It does not. Technology is producing a gadget by trial and error. Science is explaining, how the universe works, how gravity works, how electricity or magnetism works. That's what science is. That's what physics is. Then what they do is they go around persuading people, okay, to convince them, to give them a prize or, to grant them something, maybe money or a good position somewhere. And someone, they vote for it, and they say, well, if you got 50% plus one, then it becomes truth. It becomes a theory, okay, and from theory it goes to proof and truth and fact. That's the way they work in mathematics. And those who are on the losing end, they say, oh, I'm going to verify his reading. I'm going to verify his experiment, see if what he collected, all that information is correct. And so they do a verification, what is called falsification, falsifying. Okay, Austrian fellow there who came up with all that nonsense. And they finally win an award and medals and so on, so that they have authority. You win a Nobel, then you can trash anyone on Earth because who are you? I've got a Nobel. What do you have? It's that kind of thing. Okay, and so here you see the what we propose in exchange. We're saying this is the rational scientific method. This is what science really is. It's rational explanations, and that's why we're going to have to work on the word rational and the word explanation. Okay, those two words we need to understand very well in order to understand what science is. But the scientific method is a way of explaining to someone else a mechanism. In the case of physics, obviously, we do physics here. Okay, and what is a hypothesis? Nothing to do with a theory, nothing to do with an explanation. Hypotheses are the objects, the definitions, and the initial scene with which you start your theory. You have to start the movie of your theory, your explanation somewhere. Okay, and this is essentially the objects are, what objects are you going to use in your theory? What definitions are you going to use? Are they solid? Are they irrational, etc.? And then what is known as a statement of the facts. You have to base your theory on the initial scenes. If your theory, your explanation doesn't follow from the initial scenes, then you have an irrationality. I mean, hopefully the theory follows from your initial assumptions. And then the theory is the mechanisms and the causes. Okay, what caused something to happen? What is the mechanism that Mother Nature uses out there? And again, we're looking at the invisible stuff, because all the visible stuff we've already figured out. What we haven't figured out, or the mathematicians haven't figured out, are the invisible stuff. That's what we're going to be looking at. Okay, and then we have the corollaries at the end. I'm not going to go over that too much. Okay, so what does this fellow say? Well, he made a couple statements from the start in his video, and it just blew me away. I'm saying, my God, how can we, be so different, And this is what he said. Okay, this is how he starts his presentation. Give me a second here, and I'll get it started. All right, pay attention, please. Okay, here it goes. The issue and argument raised in this rejoinder is the mathematical method has done well over the last 400 years since the mathematics revolution.
The scientific method has worked pretty well so far since its inception. We've managed to find out quite a bit about the universe, especially over the last couple hundred years.
Okay, now when I heard that, I didn't need to go any further because he already said a mouthful there. First thought that came to mind is, I'm from planet Earth. What planet are you from? Please take me to your leader. Now, maybe I'm in the wrong planet. I don't know. It could be that I'm in the wrong planet and I need to find out. Maybe I went to the land of the Klingons. Maybe I went time travel to the future, maybe to kill my granddaughter before she comes back to the past and kills me first, With general relativity, you never know, So the question is, which one of us is on the right planet? Have we had success with science? Has it gotten better over time, especially in the last 200 years? Well, you see it exactly in reverse. I'm saying that we have made no progress in the last 2,500 years, since the days of the Greek at least, right? And in the last 200 years, more like 150 years, last 150 years, we went backwards. We got worse. We have more and more irrational explanations for common phenomena. We don't have rational explanations. And so this fellow says we made progress. I'm saying we haven't made progress. One of us is on the wrong planet. Okay, it could be me. Okay, well, that's what we're going to find out. Okay, so let me show you some irrationalities that I just kind of brainstormed so as to guide today's lecture. Okay, that just popped into my head. Some of them have to do with what I've been covering in the last couple weeks. Okay, so those who stuck around, you'll realize, you'll see what I'm talking about here. I'm covering some of the old ground, and serves as a summary for the month of March anyways. And here's all the irrationalities that are rampant in mathematical physics. Now, this is a very small list. I could tell you, I could go on and on and on and on. I got a list this long, okay? But this is a good place to start. I mean, this fellow says that we have rational explanations, I guess, he's thinking about, or that science is doing fine, especially in the last 200 years. And I'm saying, you know, right now we have something called dark matter out there, dark energy. And those are two irrationalities, complete irrational nonsense, poppycock. Okay, and here let me show you an example of that. Here's the balloon analogy that I covered a couple weeks ago again. Okay, and dark matter is on the inside pulling the universe inwards, and we have the dark energy, you know, kind of like the anti-gravity pushing the space outwards. Okay, and all the galaxies are really stuck to the surface of the balloon. So as the balloon grows, the theory is that all the galaxies fly apart, and that's why the universe is flying apart according to mathematical physics, right, before our very eyes. And the first question that an irrational individual asks is, what's the white stuff? That's what we want to understand. And that's an answer you won't find and they won't give you. And they say, look, hey, it's an unscientific question. You cannot ask, you know, what is the white stuff out there? And, you know, it's like asking, they say it's like asking, what's north of the North Pole? Well, you know, north of the North Pole, you have Polaris. There's a star there. And beyond that, you have galaxies and stars and asteroids and what have you. You know, so there is stuff north of the North Pole. So that's a terrible analogy or a terrible answer who someone invented and everyone else parrots without even thinking what they're saying. And the question here is that white stuff gives contour to that balloon, which is space. The balloon is space, so they're treating space as a physical object because, again, an object is that which has shape, and what we're staring at is that which has shape. So whenever you have shape, you have to have something giving it contour. You have to answer what is the white stuff. And it turns out that that little white stuff is the one they can't answer just by sheer coincidence, okay? And yeah, that is suspicious. You know, they elude the question that we want answered, okay? And here you have another version of what dark matter is. I covered that again a couple weeks ago, but let's go over real quickly over it. You see a couple galaxies on your right side there, one on top, one on the bottom. And what we show there is one star which has a certain radius from the center of the galaxy, and another one has a longer radius. In other words, it's farther out. And what the mathematicians, the astronomers out there eventually concluded is that the ones on the outside travel at the same speed or faster than the ones on the inside. And that's counterintuitive because, you know, that would be like Pluto traveling faster than Mercury around the sun. That's essentially what you're staring at there. And so how did they come up with this dark matter, which is that halo that you see around each galaxy? Okay, I made it visible. Okay, and you know, I direct your attention to the bottom left of the screen there where you see that little equation. Now you don't have to have any math to understand what I'm going to, because I'm looking at this from a conceptual point of view. You have that little v, which is velocity. We don't care about the square because, again, we're looking at it conceptually. And you see the big R, which is the radius. And the issue is, as R gets bigger and bigger and bigger, okay, the radius gets bigger and bigger in a galaxy. In other words, the star is farther and farther away from the center of the galaxy. The little v there, the one with velocity squared, the little v is getting bigger. And you say, how can that be? It's totally contrary to what the equation tells you. It should be the other way around. If R goes big, then the V should go smaller. And what they've done is to compensate for that, they invented this variable called dark matter. Dark matter is just a bunch of mass, artificial mass, that they put in the equation to compensate, actually overcompensate, to make sure that the velocity matches what they see, what the astronomers see out there in the night sky. That's the issue. Okay, so dark matter is a variable, and they turn this variable into a physical object, into particles. Okay, and now they're searching for them, and they're saying, well, what else could it be? And yes, we have a different explanation for that. You know, I've talked about that in the past several times, so I'm not going to cover it here. But the point is, these people have a variable which they turn into particles, mass, you know, which they needed to compensate for the extra radius so that the velocity matches what the astronomers see out there. And so it's a mathematical contraption, nothing but. But since they can't think of any other mechanism, they say we proved it. There is dark matter out there. And that's the majority of the mathematicians. There are others who go with Mond, you know, modified Newtonian, and a couple other people are searching for other intermediaries between one and the other. But essentially, they're looking for mass. They're saying the only way we can explain that is with mass. And it turns out, you know, dark matter, according to our theory, has nothing at all to do with mass. Okay? Nothing. Okay, so that's dark matter and dark energy. Black hole. I mean, how irrational can you get other than the black hole? This person says we've done a lot of progress in the last 200 years. What we invented in the last 200 years, at least 150 years since Einstein. Well, Einstein never believed in black holes, but I mean, you know, you had all these other people who took Einstein's equations, they turned them into a black hole, and today we have this monster called black hole. And it's an irrational entity. Only dum-dums, you know, believe in black holes. And you say, why is it an irrational entity? Well, very simple. I mean, it's a no-brainer. Okay, there is no such thing as a black hole because a black hole is zero-dimensional, zero size, and has no matter in it. And mass is the quantity of matter, if I remember correctly from high school, long time ago. Okay, so give me a second here. It's the quantity of matter, a measure of a quantity of matter. Of course, and if it's got no matter, it's got no mass. And so let's see, zero-dimensional, no volume, no size, no mass, no matter. It looks like they're talking about nothing. And they say this nothing called a black hole moves stars around and sucks the skin, you know, their gaseous skin from the star. So yeah, we have an irrationality. And these people just say, oh, they proved that they even took a picture of it. Okay, so we got a problem because these people don't understand that a black hole is zero-dimensional. No size, no nothing. They don't understand that. And they said, Bill, you're crazy. What do you mean it's no size? I mean, I have several people who told me that. They said, you know, no one says that a black hole has zero size and no volume, no dimensions, no matter, meaning no mass. Where did you get this, Bill? Okay, so let's put evidence, proof, right? That's what these people believe in, right? Authority, above all authority. I mean, some of you know a guy named Stephen Hawking. He was a British mathematician, mathematical physicist, died a few years ago. And he wrote a book, a famous book called A Brief History of Time. And, you know, some of you might be aware of that book. I guess if you've been in the industry of physics, right? You should know something about Stephen Hawking. This is what Hawking has to say. This is not me. Okay? This is, you can check it out for yourself, verify it on your own. You don't have to trust my word here, okay? And here it is, okay? This is what good old Stevie says. Okay? He's talking about Chandrasekhar, a fellow who worked for Arthur Eddington and got a Nobel Prize. And so he's explaining how Chandrasekhar, Indian fellow, won his Nobel Prize. And he won it for proving with mathematics, right? Doing mathematics, equations, that kind of thing, right? Proving that a black hole is zero-dimensional. Here it is, calculated that a cold star of more than about 1.5 times mass of the sun would not be able to support itself against its own gravity. Would it collapse to infinite density? Infinite density, ring a bell? Eddington was shocked by that implication and he refused to believe Chandrasekhar's results. Eddington thought it was simply not possible that what? That a star could collapse to a point. Meaning, what did Einstein say? Einstein himself wrote a paper in which he claimed that stars would not shrink to zero size. Let me say that again. You probably didn't hear it. Zero size. That's not me saying it. That's Stevie there. Okay? However, he was awarded the Nobel Prize in 1983 for his early work on limiting mass of cold stars. Chandrasekhar had shown that the exclusion principle, right, quantum mechanics, could not halt the collapse of a star more massive than the Chandrasekhar limit. Zero size. You say, well, it must have been a typo. Okay, so let's go to his other part of the book, his book. It says the following, as Penrose showed. Penrose, a fellow also who just won a Nobel Prize I think last year, showed that a star collapsing under its own gravity is trapped in a region whose surface eventually shrinks to zero size. So we have all these people proving zero size black holes, singularities, okay? And since the surface of the region shrinks to zero, so too must its volume. All the matter in the star will be compressed into a region of zero volume. Is anybody hearing me? I'm talking about zeros here, okay? Zero size, zero volume. In other words, one has a singularity contained within a region of space-time known as a black hole. Okay, now, this is not me. I didn't invent this, okay? You can find it in the book. I put the pages there so you can check it out on your own, because a lot of people say, Bill, you're crazy. What are you talking about? Zero size. Yeah, it's zero size. Black hole is zero size. Why would a black hole, a star, right, that's collapsing on it because of its own gravity, why would it stop at, greater than zero? What would be the mechanism of stopping right there so that you can say, well, there's still something there? A lot of mass compressed into a little tiny thing. No, it's not infinitesimal. It's zero. Okay, let's make sure we understand it. Black hole is zero size. There is no such thing as a black hole. Okay, and you say, well, Bill, that's only one source. Okay, let's put another one just to make sure that we have all the evidence on the table. This fellow, he's a fellow over there in Cambridge, and Cambridge University Press published his book. He was a professor for several years. I think he still is. On solving the equation with a particular value rho of central density, you will get a model of a star with mass m and radius r. Okay? Plot r as a function of m and show that r falls to zero. Radius falls to zero. Zero radius. Okay, I hope you understand. When m is equal to Chandrasekhar mass. If you can do all these, then you have repeated the calculation for which Chandrasekhar won the Nobel Prize. I hope you understood some of that. We're talking about zero, 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 zero. There's nothing there. And let me rub it in just while we're at it, okay? Here we have two fellows, Professor Cole Miller, University of Maryland, and Professor David Harrison from the University of Toronto. Black holes are the most exotic objects in the universe. A black hole is a region of space. The matter that forms a black hole is crushed out of existence. There is nothing there. Okay, I hope that struck a bell somewhere, okay? What does Harrison say? An object whose gravitational pressure is so intense that the matter of the object is crushed out of existence. Okay, so we have no matter, okay, and we have no size, no volume, no dimensions. Okay, so the question is, what do we have? What are we talking about? What's left? And so here it is. As far as I know, mass is a measure of the quantity of matter, or you need something related to matter to have mass? I think so, okay? Well, here we have it, okay? We have all these folks, the dictionary, the Wikipedia, all of them say the same thing. Mass is a measure of how much matter an object contains. Turns out a black hole crushes all matter out of existence, okay? And so if mass is the quantity of matter and the black hole crushes matter all out of existence, we have no mass whatsoever according to the definitions of mathematical physics. So far we have absolutely nothing in front of us, okay? So no, there is no such thing as a black hole, because a black hole by definition is nothing. They defined nothing. And then they took a picture of it and they showed it to the world. Okay? They showed a drain there with water going around. They said, well, the black hole is you can't see it there. Is that a black hole? The picture you took? No, that's matter rushing into a black hole. So where's the black hole? Well, it's the zero-dimensional singularity that has no size that's in the center of that. Okay? So that's how they sell these things. And people just buy it because they don't understand anything. They don't question anything coming from the mathematical establishment. Okay, how about Big Bang there we have? Next one down on the list. Here we have Big Bang, okay? And I showed this the other day, okay? Our universe, according to mathematics, space, time, and matter are all in there. So we have space, time, and matter inside that tilted glass. That's pouring beer out. Makes me thirsty, okay? Anyways, so we had all these years, we have this thing. It's been around for almost 14 billion years, okay? It's called the space-time, the blocked universe, whatever. And the question is, how did this start? How did the first bit of matter start? And the way they calculate, or the way they figure this theory out, is they said, look, we figured out in the 1930s, 1929, 1930s, that all galaxies are expanding, are flying away from each other. Okay, so the world is exploding. They say, we got it, we understand this. What's happened is yesterday we were closer together, and even before yesterday they were even closer together. So if you run the movie backwards, what you have is all matter condensing into a little point, a singularity. And you say, well, where did the singularity come from? I mean, can you tell me that? And they say, well, no, that's unscientific to ask that question. We don't know. See, the theory stops at frame number 2 of the film. And I showed the other day, here it is. That's the movie of the Big Bang. You know, it starts at frame number 2. It doesn't go to frame number 1 where the singularity is created. They say, we don't know what happened there. We can't explain it. It's unscientific because we have no way of proving, blah, 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 blah. And essentially what they're saying is we cannot explain the mechanism of how something comes into existence from nothing. That's essentially the problem. And that's when the religious folk, you know, they look at them and say, they smirk and they say, you just don't want to say that it's God who made all this stuff, right? That's all your problem. And yeah, this is the issue. In that sense, I got to side with the religious folk, the traditional religion, because they've got the right idea. You know, why did you stop at frame number 2 and say, well, we started at the singularity? Well, how convenient. I mean, why didn't you start at, you know, before the singularity? What happened? Well, another answer they give you is, like I said, you know, when I analyzed some of the religious folk like St. Augustine and St. Anselm and St. Thomas Aquinas, you know, and they all had this idea that God is outside of time. God made time, you know. He made all the time he could. And so he made time, so he's outside of time. And these people are more or less saying the same thing, that time began with the singularity. And so the religious folks smirk and say, we know what you're trying to say. You're trying to avoid God, all you atheists, right? Yeah, they're right. They're totally right. That's the issue. They're trying to avoid, you know, God. God made the singularity, and the question is, you know, they say, well, we don't need God, and that's fine. You don't need God, but then you have to have an explanation of how the singularity came to be. You can't avoid that. You can't sidestep that question. By sidestepping, it ruins your entire theory. Your theory is bunk. You cannot say the galaxy going back and back and back until we reach frame number 2. If you can't take it to frame number 1, you don't have a rational theory, because that's the issue. The issue is, how did something come in from nothing? Can you explain that? And they do have, I don't know if you can call it an explanation, an excuse. That's probably a little better. And here it is, okay? This is what it looks like. And it's a whatchamacallit, someone asked the question in Quora, and PhD answered the question. And it's how this question was answered that's important, okay? And which answers the question of how the universe came to be, how matter came into be. Okay, and here it is. It says, is it true that in quantum mechanics, particles can appear and disappear seemingly from nowhere or without a cause? And a PhD, this is a PhD, okay, he answers, QM obeys physical law, not magic. Oh, okay, good, thank God. And says, yes, the way things behave at the quantum level is often weird and very non-intuitive. bad way to start a presentation. He's going to say that it's counterintuitive. Okay, I guess we're heading into irrationality here. And yes, during high energy collisions, all sorts of particles can appear, disappear out of the vacuum that were not even there to begin with. Okay, sounds like magic. But again, all this goes according to well-established theory, quantum field theory, not magic. So that's just a statement. These people are doing magic and saying, no, no, ours is not magic. Magic was what the traditional religions did. We don't do magic. And so you see where the problem is. These people are doing magic. They're saying it's science. And so, yeah, this fellow, he was educated with all this stuff, time dilation, some of the others there. I'm not going to go over all those. But he was educated with all this stuff. Or read about him, I guess. And he just accepted it at face value on the basis of authority. The mathematical physicists, the scientists, they fed it to the world, and he said, well, they can't all be wrong. I mean, the guys in Cambridge, the ones in Harvard, the ones in Caltech, the Chinese, the Russians, all these people are wrong, Bill? They're not wrong. They're all irrational because they don't care about mechanisms. That's why they're irrational. They give you a bogus physical interpretation saying, well, we moved the energy in this direction. We moved the field over there, and then the mass was kicked out in that other direction. So they talk about all these concepts, and people say, whoa, that's over my head. I guess you know, because all you mathematicians know all those equations, and you talk about mass and all this stuff we don't understand, so you must be right. And essentially it amounts to what happened in the Middle Ages, where the only person in the village who could read was the priest. And so he would tell them what the Bible said, and everybody else had just to accept, whether they liked what they were hearing or not. They had to accept it because the only guy who could read was the priest. And we have these priests, the modern day priests are the mathematicians. They've been handed this, the mathematical world, and people say, well, I don't understand all that stuff, so I'm just going to rely on what he says. And when all the mathematicians say, we all agree, space-time, black holes, dark matter, particle at two places at once, people say, well, it must be true because they can't all be wrong. So it's an issue of authority, nothing but, okay? If they're all irrational, if they're all flat earthers, we're all screwed, okay? That's the issue. Okay, so here's an example, okay? It's famous space-time, okay? And you have two versions of space-time. You have the ridiculous 2D space-time and the ridiculous 3D space-time. And you can see that one is sitting on top of space-time. The other one is drawing space-time towards its center. In this case, the Earth, right? And the question is, these two cannot both be right. And so these people put these things out there, and they get thousands of hits, and people say, ooh, and ah, and oh, that's so great, that's so fantastic. And they don't even know what they're staring at. They don't even know if this matches in any way, what Einstein said. And it turns out that they don't, because Einstein, first of all, said that, you can only apply relativity out there. And a lot of these folks don't know it. There's this fellow who goes out there and says that he's going to prove warp space in his basement. And he goes in there and he does the Cavendish experiment in his basement. He says, oh, I proved that, let me put this out of here for a second. And I proved warp space in my basement. No, you can't. Space-time doesn't work down here. I can't explain using Einstein's equations, okay? I cannot explain why this pen drops to the table. I cannot explain it with I cannot apply Einstein's equation to here. You can only apply Einstein's equation with big masses out there in the global universe. You cannot say that space is so warped here that this falls at that rate. That's why it's falling. Okay, and so again, these people have these notions. Let me get it back up here now. Okay, and one guy says 3D space-time. No, that's not what Einstein said. So this guy thinks he's very smart because he said, oh, I figured out how space-time really works. No, space-time works like the one on the left. For otherwise, Mercury's orbit, which is up there in the center, wouldn't work. Mercury's orbit, the one Einstein applied his theory to, works like the 2D space-time, the ridiculous 2D space-time on the left, the two-dimensional one. Okay, so which one should you choose? Should you go with the one on the right, which is a totally different mechanism than the one on the left? That's the million-dollar question. Well, I'm a guy who believes in authority and in what is democracy, people who will majority rule. Everybody votes for flat earth. I'll be a flat earther then, okay? I got to be a flat earther because majority rules, right? And so I'm going to go with the head honchos of mathematical physics. And here we have one. His name is Brian Greene. And this is his version, which is the one on the left that you just saw, okay? That's his version of why the moon doesn't fly out of the solar system. Very straightforward, okay? We have a depression, this surrealistic depression, a two-dimensional cross-section of space-time, I guess. And the moon doesn't fly away because it is trapped within that depression, like a little ball rolling around a roulette. Okay, so I don't know what part you didn't understand there because it's very straightforward. It's illustrated, and Brian Greene, he's a PhD, right? Celebrity, etc., etc. Okay, so he should know. Okay, so you got to follow him because he knows his stuff. He's done all that math. He should know whether the Earth or the moon rolls around, a depression caused by the Earth, or whether it's being pointed towards the center of the Earth and to the center of the moon and to the center of the sun. Which way does the space-time gravity work? Okay, so you got to figure out which of the two. Those two can't be both right. Okay. And just to rub it in, I'm going to go also with another source, which is also authoritative. Okay, so here it is. That's NASA. NASA also has the Earth weighing down the canvas, not the canvas being dragged into the center of the Earth. Okay, so we have to go with this version of gravity according to Einstein, according to the folks in NASA and all the PhDs out there, right, who do mathematical physics. We have to go with their version and not to the people who think they invented something new by pointing by drawing the fishnet inside the Earth. Okay, so what is the mechanism? Why doesn't the Earth fly out of the solar system? Why doesn't the moon fly out of the Earth orbit? Okay, what's keeping it there? And here we have it. Okay, this is what the theory says. The irrational theory of general relativity says. Here it is. Okay, this is the curved wall of time. They say time is a physical object like a wall. The Earth rolls around or slides along this curve, and that's why it doesn't fly out of the solar system. Very, very similar to the analogy of a roulette. You have the little ball going around the roulette. Why doesn't it fly out of there? Because it's got this wall that's preventing the little ball from flying out. And this is no different. Okay, so it's the roulette mechanism. And then what these people say is, when you show them this, you say, well, is this what you're saying? You're saying time is warped. Are you saying there's a canvas there that comes against the skin of the planet? Is our planet rolling or scraping around that depression? Is that why the Earth doesn't fly out? Because that's what they've explained. That's what they illustrated. That's what they told you, objectively. And then he said, Bill, you're not supposed to take the analogy literally. And here, this is what they show you. Okay, they show you this little cartoon. They say, understanding gravity, space-time is like a rubber sheet. Massive objects distort the sheet and, wait, they distort it because they're pulled down by what? And the teacher, loses patience and says, space-time is like the set of equations for which any analogy must be an approximation. Wrong. Okay, it's not that, it's an analogy. You have to explain the mechanism of why the Earth doesn't fly out of the solar system. If you're going to go in there and say, well, there's a depression and the Earth rolls around it and blah, 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 and then at the end of your class you say, oh, by the way, that was only an analogy. There is no depression. There is nothing coming up against the skin of the Earth. Then what have you said? What is your mechanism? Okay, so this is the issue. These people... give you a 2-hour explanation. They show you the pictures, they describe the pictures, they show you the whole works, they explain the mechanism, and you say, okay, I understood it because you see all the objects on the screen or wherever. And then they say, oh, by the way, that depression, that's not there. It's just an analogy. You're not supposed to take it literally. Great. Okay, so here we have the Earth, because you're saying, okay, but they were able to explain many things with this. Okay, for example, certain orbits and so on with these equations. Not explain them, but really describe them. Okay, and the question is, does the mechanism, that general relativity that Mr. Einstein proposed, is it rational? Can you use this to simulate what's out there? And they say, yeah, it is, because see, we were able to explain, like, and this fellow mentioned that, he says that there's no planet called Vulcan that's close to the sun, somewhere between Mercury and the sun, because they had to try to explain the orbit of Mercury. And Leverrier tried to explain that, and he couldn't. He died. He thought there was a planet there, which was later named Vulcan, because he's the guy who discovered, the Neptune. And so they said, just like he did that math and figured out Neptune, maybe we can figure out, what is it? That there's a little planet there that we can't see very well that's between the Earth and the sun. And he says, thanks to general relativity, we didn't need that planet. We could explain the orbit of Mercury just with equations. And what he doesn't understand, this fellow, and 99% of humanity out there, is that mathematics is tautology. What they do is they make an equation that describes what they're observing. So it better be a tautology if the equation is correct. It's just a tautology. It means that you're making a tailor-made equation so that it fits the observation. And that's what Einstein did with Mercury. He just went in there, put some variables in there. He said, see, if we put it this, and this way, then we can explain the orbit. And what is Einstein's equation for Mercury is that it's a point mass. Okay, to use that terminology, it's a point mass. It describes the motion of a point mass around the sun. That's what Einstein's equation does. That's different than Newton's, which said, look, there's two objects, and they attract according to the inverse square of the distance. Okay, so the notions are different. And in the case of Einstein, it's just a point mass that moves around the sun, and you're describing that path. So it is a tautology. That's why it works, more or less. Maybe there's I think it's not perfect on the money, but it pretty much resembles what Mercury does. That's a description. We still don't know the mechanism. Why doesn't Mercury fly out of the solar system? And that's when they bring in the canvas. Okay, so what's the problem with the canvas? Why is it irrational? Okay, why doesn't it explain? It explains Mercury. Great, I'll concede. It explains Mercury rolling around the sun. What doesn't it explain, which is 99% of the other stuff? And here is what it does not explain. Okay, here we have the Earth and the Moon rolling around the sun. Okay, so we have the sun weighing down the canvas. Okay, and then around that we have the Earth. It also weighs its little canvas, which is rolling around the other canvas, right? And the Moon has to roll around the canvas that the Earth created. Okay, so far so good. They're both the two canvases, the one for the sun and the Earth, in fact, even for the Moon, they all point downwards. Okay, and we don't know why they point downwards, but we're not going to get into that right now. I just want you to focus on the fact that the fishnets, right, the canvases, okay, they're all parallel. The one for the Earth, the one for the Moon, and the one for the sun, they're all pretty much parallel. They're in the same direction. Okay, what's the problem with this? Well, the problem with this is here. Okay, here you have the Earth on the upper right, and that's correct. They all are parallel with the ecliptic, essentially, right? In other words, the canvas there matches the canvas of the sun. But that doesn't happen with Uranus and its big moon Oberon. Okay, Oberon goes around the equator of Uranus, but Uranus is on its side. Uranus twirls towards the sun. All these are views from the sun, by the way, okay? So you have Oberon, the biggest moon of Uranus, and it's going towards in the direction of the sun over the head of Uranus, which is on its side. In other words, Oberon is running around its equator. The north-south is in the east-west direction. Okay, so Jupiter is on its side, and it has to be pushing the canvas towards the side. I chose one side. It could be towards the other side, but it doesn't matter. It would point east in this case, or it could point west, in order for Oberon to orbit the Uranus the way it does. Okay, so we have a problem because the Earth weighs it downwards, and our moon weighs it downwards because they all are parallel with the sun weighing the canvas downwards. But Oberon and Uranus falsify that. You know, Oberon twirls towards the sun, and so does Uranus. Its north and south pole are sideways. And what happens with Pluto and with Charon, its biggest moon? Well, again, you see there it forms a bullseye pattern as seen from the sun. Okay, so Pluto would have to push the canvas outwards or inwards towards the sun in order for Charon to orbit the way it does, you know, in a bullseye pattern as seen from the sun. So the problem with Einstein's explanation is that it cannot explain these three different mechanisms, you know, with its canvas analogy. You know, how do you explain it with a canvas analogy? If the sun weighs it downwards, why would Uranus push the canvas sidewards, and why would Pluto push it outwards? That's the issue. And here, let me bring this other. Give me a second here. This is a summary of what Einstein's theory is, his explanation, his physical interpretation of how these moons work. Okay, you see the sun weighs the canvas downwards. You can see the white arrows below each one of the suns there. Okay, in the case of the Earth, no problem. Everybody points downwards. In the case of Uranus, it has to push the canvas sidewards in order for Oberon to twirl around the canvas, the roulette mechanism, over the top and towards the sun. And in the case of Pluto, Pluto would have to push it outwards or inwards towards the sun in order for Charon to twirl around in the direction in which it does. So Einstein's theory does not work. His explanation does not work for a three-body system. Okay? And so here they have all these tests of relativity that you'll find out there in the Wikipedia. And they say, oh, these confirm relativity, general relativity, okay? And maybe they should include, you know, the one is, I mean, there's several. I mean, I'm just pointing to one problem there, which is, you know, in the direction in which the moons orbit. And Einstein cannot explain that with his, you know, with his mechanism, the mechanism that he proposes for gravity. He cannot explain it a three-body system. Okay, so this is the issue. And they should include that. See, they never include that within the failures of general relativity. They say everything's been confirmed. You know, and what are you going to confirm for a black hole? Zero-dimensional nothing? What confirmation do you have there? You know, what proof do you have that there is a zero-dimensional matterless, meaning massless, entity out there that's moving stars around? Dark matter, what have you confirmed about dark matter? That there's this invisible variable that you put in an equation and that you're looking for now in the night sky? Again, all these are failures of general relativity, and nobody mentions that. They just mention stuff that they measure, and they say, oh, we've proven everything. In fact, they put detection of black holes. And they show that ridiculous picture that they published, and they got so many kudos for. Okay, so what's the underlying problem of all this? Well, the underlying problem is that mathematical physics, mathematics, does not use physical objects. And why don't they use objects? Well, because the mathematicians never defined what an object is. They have no use for objects. They only deal with equations, with behaviors, and they don't care about, objects. They do not care about simulating things with objects. And you can see where the problem is. If you go through the literature, any literature, scientific, so-called scientific literature out there, like I do, read papers, and what you will never find, or rarely, I think almost never, is a picture. Here we have physics, which should be a discipline that should be full of pictures. You should have all these pictures showing mechanisms and so on. And you go to these so-called scientific literature, and all you find is equations. You'll never find a picture. Why? Because it's outside of their job descriptions. It's below their pay grade to put pictures in an article, in a paper. And so this is where the problem is. Physics, we say it's causes and mechanisms. The only way you can explain a cause or a mechanism is if you have objects, because you have to simulate it with some kind of object. You got to show us the mechanism. What mechanism are you going to show if you just put an equation? What have you shown? Okay, you haven't shown a mechanism. All you have is a description, a mathematical description of something you measured. But never an explanation of what caused that to happen. That's the issue. And so no, physics, the language of physics is not mathematics. Okay, if physics has to do with explanations of mechanisms, and if it does, then the language of physics is illustration. You have to illustrate. You have to illustrate the singularity at the beginning of time, Big Bang. You have to illustrate dark matter and show us how it produces this mass that, in other words, how does it keep that star on the outside from going faster? You can't just say there's more mass there, because that's just a description. You haven't told me the mechanism, what causes it to go faster. All you have is a description of the fact that, there's more mass, and according to the equation, it should go faster. That's all you've told me. You haven't told me anything about what is the mechanism. In fact, they use Newtonian law for that, the gravitational law. And Newton said, fingo non hypothesis. In other words, he said, I have no hypothesis, no theory. He had no explanation for how that works. Okay, so you need objects. You need objects to explain a mechanism. And I'll give you an example here, I need to explain to you how the steam engine works. Long time ago. Should be straightforward, and here it is. I illustrate it for you, so that you can understand the mechanism just by watching the movie. And here it is, Feed coal into the furnace, steam pushes the piston upwards, Introduce cold water and the piston comes downwards. Now, how difficult can that be? Anyone who watches this should say, okay, I understand how the steam engine works. Why it goes up and down, because you have that furnace at the bottom, steam pushes it upwards, cold water pushes it downwards. Straightforward. Did I need any math? Do I need to know how much energy? Do I need to know mass or field or any of those parameters? Do I need to know force? No, I'm just trying to figure out what the mechanism is. And a 10-year-old can tell you what the mechanism is here. Heat pushes it up, cold water pushes it down. We're done. See how easy it was? No math, no nothing. That's what we want for gravity. We want an explanation like this, a baby one that a 10-year-old can understand. What did Einstein say? If you can't explain it to a 10-year-old, you don't know it well enough, or you don't know it at all. Feynman says something similar. Or to a barmaid. Okay, so this is the issue. The issue is we want an explanation for what causes the pen to go down. If that's science, we haven't made any progress in the last 2,500 years, and we only proposed irrationalities in the last 200 years. opposite of what this fellow said. Okay, okay, so here I'm going to show you a little picture which I put in the science series. Okay, and I want you to tell me objectively, okay, what caused the window to break. Okay, see if you can figure it out. I mean, this is difficult. I know for some of you who are not used to seeing images, watching movies, it's very hard on your eyes or whatever. Okay, so here it is. So you have to tell me what caused the window to break. Here it is again, just in case you missed it. Felix revolves it and throws it, and looks like, I think anyone on the planet would say that a horseshoe went through the window. That's what broke the glass. Okay, was it difficult? One more time, just in case you missed it. Okay. Now, this is what we call objectivity. I should get every person on the planet who is more or less sane, right? and ask them, how did the window break? And the person should say, that window, that specific window. Person should say, horseshoe went through the window, broke the window. I'm not asking them anything about mass and force and energy, whether he ate an ice cream. I'm not asking stuff out of the ordinary. I'm asking, how did the window break objectively? What did you see? Every person should answer the same thing. That's known as objective. And why we could see, because we could see every single object in the movie. We could see the horseshoe, we could see the glass, we could see, Felix waving this horseshoe around. The horseshoe goes through the window and breaks it. Every person on earth should answer the same thing. Anyone who doesn't has a mental problem. What did this person answer? This is what he answered. Let me put this up here. He said, no one can objectively tell you what happened there, especially seeing as they're just cartoons. I couldn't believe his answer. So if I ask a 10-year-old, what are you seeing there, 10-year-old? What's happening there? And I think if I go to kindergarten, all the kids would say, well, Bugs Bunny jumped or dived, he dove into a rabbit hole. That's what they would say. That's what you're staring at. That's objectively what's there. But he says he can't tell me objectively what's there because it's a cartoon. That was his answer. I couldn't believe it. Okay, but you see what kind of people you're dealing with. Either they're making themselves hard to catch, or they don't want to be, caught in their lies or in their contradictions. So they say even more dumb things like, I can't tell you because it's a cartoon. I can't tell you why the window broke. I can't tell you that, Bugs dove into his, his hole because it's a cartoon. And this is the problem with these people. Okay, so now someone comes to you, okay? Someone comes to you, he's a religious folk, someone from the traditional religions, and he says, I've got a theory of gravity. Oh, okay, what's your theory of gravity? He says, here, I'm saying that angels mediate gravity. I say that angels carry astronauts to Earth. They force, angels that are here, they force the pen to fall, and so on. So I'm a little skeptical. I'd have to see it. Okay, I've illustrated it for you. Here it is. I'm going to show you. Okay, and so here he puts this up there for you, okay, so that you can verify what he's saying, the mechanism. And here you have the angel carrying the, astronaut to Earth. He says that's how gravity works, according to me. And you might go in there and say, well, I don't believe in your theory. What experiments have you run? I don't believe in angels. I don't even believe in God, so, I think you're wrong. Have you done any experiment? What's the equation? Can you show me something? Wrong questions. Wrong questions. The person is saying, giving you a mechanism. He's telling you a mechanism of how he thinks, what he proposes of how gravity works. We're not asking you to believe in his theory. We're not asking you to, what's the evidence? How many people have voted for your theory? We don't care about any of that. We want to understand what's in his mind as far as what he proposes for the mechanism of gravity. And there he's showing, he's saying angels carry it down to earth. And the question is, did you understand the mechanism that he's proposing? That's the question. And if you didn't understand it and you say, well, it's just a cartoon anyways. Well, then you got a problem. You got a mental problem. Yeah, you got a mental problem because the question is, do you understand the mechanism that he's proposing? That's the question. That's what's before us. We're not talking about evidence. We're not talking about who believes in it. We're looking at the mechanism. Okay, so now there's another fellow. He comes up and he says, look, I've got a theory of gravity. Okay, what's your theory? Well, I say that all atoms in the universe are interconnected. And so every atom from the Earth is connected to the astronaut. And so as he approaches the Earth, the ropes, in this case, right, they fan out, all these elongated entities fan out, and he accelerates ever at a faster rate. So he goes faster, faster, faster. We call that acceleration, and that's the acceleration of gravity. Well, can you illustrate that mechanism for me? Yeah, sure. And here the fellow goes in there and he illustrates it for you. And he says, here it is. Okay? He didn't draw all the elongated objects there because it would be a gazillions. He just illustrated a few so that you can understand the mechanism of what is bringing the astronaut to Earth. Why he falls to Earth and not to outer space. Why? Because the Earth is very close by, again, and consistent with Newton's equation, so we're all safe there. Okay, so the fellow falls to Earth, the astronaut falls to Earth, because every atom in his body is bound to every atom that comprises the Earth. That's the theory. Okay, and the question is, did you understand the theory? And the guy says, well, I don't believe in your theory. I don't see any ropes or anything, between any two atoms. I can't touch them. So where did you come up with this? And why can't I touch them? And so on, And so the issue is, did you understand the mechanism? That's the only question. The question, did you understand the mechanism? And the guy said, well, no, I don't understand because it's a cartoon. Okay, what are you going to do? The guy doesn't understand because it's a cartoon. We're asking him to understand why the window broke. He doesn't understand it because it's a cartoon. He doesn't understand why that bug dove into his hole because, it's just a cartoon. He doesn't understand that the angel carried the astronaut to Earth because that's just a cartoon. And he doesn't understand the ropes because he says that's a cartoon. And so, we're talking about mechanisms here and he doesn't understand it. Yet he understood probably, I think, the steam engine. And you say, why did you understand that? That was a cartoon too. Yeah, but that's real and I prove it and I've got evidence and everybody voted for it. So he believes on the basis of authority because that's a cartoon too. That was a drawing. And so this is the issue. The issue is people are confusing belief with objectivity, what we have in front of us. If I ask every person on earth, what did you just see? They should all say, any rational human being should say, the astronaut, every atom in his body was tied to every atom on earth. And so he fell because, the ropes got closer to the earth. Now, maybe they're elastic. We don't understand that yet. There are other problems. But the issue is, they should be able to give you in general terms that the astronaut fell to Earth because every atom in his body is bound to every atom on Earth. He's tied to the Earth. That's the mechanism. Now, we can go into more detail later on, but the issue is, we're talking about mechanisms here, whether you understand the mechanism proposed. If you don't, well, we have to say a little more maybe so that you understand it better. But to say, well, I can't understand because it's a cartoon, well, not very smart. And you say, well, where'd you get that anyways? I mean, where'd you come up with all this nonsense about, all atoms being interconnected and so on? Well, here it is. Okay, here's, for those who want proof and evidence, we don't deal with this in science, but here you have proof, evidence, authority, all the stuff that you always wanted. Okay, Here you have Mr. Richard Muller, professor at Berkeley, says, so for example, if you have the Earth, there's a big mass here, and you have you with your little mass here, every atom on Earth is pulling on every atom of you. You're also pulling on it. The amazing thing about gravity is that it goes right through things. Okay? So yeah, if every atom of you is pulling on every atom on Earth and vice versa, it means every atom of you is connected, physically connected to every atom on Earth, because otherwise you're introducing black magic. You're saying that one atom pulls on you, but there's no connection, no physical entity between you. That's what you're saying. Okay? So this is the issue. The issue is mechanism. And this person, this individual, apparently does not understand that. He thinks that science is about just math and authority and just believing in what the people in Cambridge and Oxford and Harvard and Caltech, just feed him. And hopefully not. Hopefully science is about, like what he did here, questioning the instructor or the theorist or whoever, question them. And the question is, did he ever question his instructors, his teachers, or what he read? Did he ever question that? Or did he just accept and say, well, black holes have been proven, so yeah, I'll accept that, and I'll accept dark matter, and I'll accept dark energy, and that a particle can be at two places at once, and blah, 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 blah. Why? Because it's being fed to him as proof and truth and fact. That's the only reason he believes in it. He has no argument. I mean, he could just as well raise the arguments he raised in my videos against those theories. Why did he ever do that? And I'm almost sure he did, because you find people like Joe Rogan and so on. They interview all these people, the celebrities of math, and they tell me, yeah, there's several universes, and particles come out of nothing, and we have all this black holes and dark matter out there. And he never questioned it. It's like, oh, okay, that's nice, that's interesting. Then he brings another celebrity who tells him the same thing, and they all just accept it and accept it and accept it and accept it. No one questions it. What do you mean, black hole? What do you mean that particles can come out of the void? What do you mean that a particle can be at two places at once? Nobody questions that. They just accept it because it comes through the channel of authority. That's what it's called. Okay, let me get on to a couple questions and then open the floor for rational questions. If you put BS there, I'll skip over your questions, okay? So think of good questions, okay? Put me on the spot. That's your job, okay? My job is to answer. Okay, fellow says here, he says, clickbait. He says, your title, Quantum Tunneling, is easy to understand. The false clickbait title is something that should be addressed with YouTubers and embarrassed off the platform. And this title of yours included. You didn't explain anything the same way that they didn't observe their findings. I came here hoping you might have an explanation that was better than those just repeating what they were conditioned to repeat on this topic. I didn't get that. I hate bogus titles on videos. Okay, he was talking about that video. I've got the link there, and quantum tunneling is easy to understand. That's what I call it. Well, the first thing I have to tell this fellow is that, I don't do clickbait at all. I mean, you should have figured out by now that I don't get that many views. I mean, I'm not in the business of clickbaiting. No, I put a title either to embarrass quantum mechanics, general relativity, string theory, mathematical physics in general, or sometimes it's appropriate to the subject matter that I'm dealing with. In this case, it was appropriate, as I saw it, okay? Not for clickbaiting, but so that people understand that it's easy to understand quantum mechanics. It's just nonsense. That's what you have to understand. And I talked about entanglement and other things. And yes, I explained in that video exactly what I was talking about. So I don't know why this fellow didn't catch that. I don't know if he didn't watch the whole video, but I watched it the other day to see if I missed something. No, I think I explained very well the issue of entanglement and some other problems with quantum mechanics. Okay, same fellow, but this is another question he raised, and this one got to me a little deeper. Okay, he says the following. He says, if you can take that negative energy, you have for the system, and refocus it from trying to embarrass or make examples of the conditioned thinkers out there to ideas of or individuals that are breaking outside the box would be so much better than just downing and negatively bashing those ideas or individuals you don't agree with. Don't show me just the parts you find as irrational. Point me to ways, places, or individuals that will help rationalize some of nature's mysteries. Okay, some of his points are well taken. My son Hans, he also beats me up sometimes, saying, "You beat up people." Yeah, I say that I don't beat them up. I treat them with the respect that they deserve. That's different. I don't insult them. I'm just treating them with the respect that they have earned, and yeah. But this is my challenge for this fellow, this gentleman. Okay, this is what I suggest. Here's a thought, because I talked a lot about what's happening in the mathematical world, in the so-called scientific world out there, all the censorship, all the fact that we don't have a level playing field, the fact that they dismiss all people who disagree with them as cranks and crackpots. They have all these things that they put in place to belittle anyone who questions general relativity and quantum mechanics, primarily, and also string theory. And so, I have something. I have a reason for doing my stuff. I've been at this for 25 years, and I received a lot of punishment over the years. I've got very thick skin, by the way. So if anyone says something bad about my mother, it doesn't hurt me at all. I can sleep well at nights anyways. But this is what I suggest. This is the deal I'll make with this gentleman. Okay, here it is. Okay, this is a fellow known as John Baez. He's Joan Baez's cousin, by the way, a singer. And I'm going to look at points 11 and 20 here. Number 11 says 10 points for each claim that quantum mechanics is fundamentally misguided without good evidence, and 10 points for each favorable comparison of yourself to Einstein or claim that special or general relativity are fundamentally misguided. He created the crackpot index. The crackpot index is at that location there at the University of Riverside, University of California at Riverside. It's been there for over 20 years. And it's Riverside is a university partly maintained by public funds. So here's my challenge to you. I want you to write a letter, okay? Instead of complaining against me, write a letter to University of Riverside and get this nonsense that Baez put up there on taxpayers' money and maintaining there for 20 years. See if you can get it out of there. When you get it out of there, I'll make sure that I never bash a mathematician again. And then I want to point out to number 19 there, 10 points for arguing that while a current well-established theory predicts phenomena correctly, it doesn't explain why they occur or fails to provide a mechanism. So yes, here's the problem. Mathematical physics does not provide mechanisms, okay? And so we have a big problem here, because that is what science is about. That is what physics is about, mechanisms. And that's what these people are really trying to find out, because they say, we're trying to explain gravity, but they never explain it. They only describe it. And so you say, well, why does this pen fall to the ground? Why doesn't it fall to the ceiling? And they cannot answer that. What they do is describe it mathematically and say, well, there's more mass. That's a description. You haven't explained to me, what does mass have to do with anything? How does mass pull on the pen? Pen is real, mass is a concept. How does mass, the concept, or gravity, the concept, pull on the pen? What is the mechanism? What came in contact with the skin of the pen? That's what you got to answer. And if you say nothing, then you're doing black magic. And if you do concepts such as mass and field and wave and all that nonsense, then it's even worse than black magic. Then it's total irrationality. And that's what we have in the last 150 years. Just irrational explanation for how the pen, what caused the pen to fall to the floor. So, we call it irrational. Here are the criteria for irrationality. Okay. Treating concepts as objects. Reification, we call it. Congruitization. If you treat a field, you use the word field or the word energy as physical objects, you are an irrational individual. You have an irrational theory, because a theory is a mechanism and you're trying to explain the mechanism using a concept. You're saying the concept pulled on an object. That's what you're saying. Okay, that's the primary one. There's a couple more there. I'll let you later on read it. Let me move on here. We'll move on to another fellow here. Says the following. We were dealing with time last time. This fellow addresses this issue, which is good. Okay, he says, a second is a measurement of time. Okay, good. It's a measurement, right, of time, whatever time is. He says, time is change, or the interval of change. And he says, only one motion that repeats predictably is needed to have a measure of time. Well, there we have a single ball. What is the time? The only way you're going to figure out time is if you have a clock or something else that's moving and you compare that motion against the motion of the ball. If the ball is the only object that God made in the universe and then he disappears, so there's only one object, or that's the only object that appeared in the universe, a ball, and it's moving through space, just a ball moving through space, what's time? What's the time? Is it 10 o'clock? No, motion is a synonym of change. Change and motion are exact synonyms. That's why you cannot define the word motion using the word change. So you cannot say motion is the change, and you're already screwed, because change is motion, motion is change. You can't use the word change, can't use a synonym to define a word. So you can't use the word change, and that's motion. But time is not just motion, and time is not just change. There's a little more than change. There you have change, you have motion. Okay? So where's the time? For time you need another motion. Okay? So this is the issue. No, time is not just change. Time is not just motion. Okay? Same fellow, I think, says up there, 1967, the 13th General Conference on Weights and Measures provisionally defined the second as 9 blah 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 cycles of the cesium-133 atom. Okay, atomic time clocks are the most precise timekeepers in the world. Well, this poor fellow, I guess, is not aware, but there was an experiment. There are several experiments, but I'm just going to mention one of them, probably the first one or the most important one, and it's known as the Keating experiment. And it says, was a test of the theory of relativity. In October 1971, these two fellows took 4 cesium beam atomic clocks aboard commercial airliners. They flew twice around the world, first eastward, then westward. You see that at the bottom right? And compared the clocks against others that remained at the United States Naval Observatory. Okay? When reunited, the 3 sets of clocks were found to disagree with one another. That's how accurate the atomic clocks were. They flew them just a little height above sea level, and they were completely inaccurate. And this fellow says, let's look at it again. It says it's the most precise timekeepers in the world. And no, let's make sure we understand. The most precise timekeeper in the world is the orbit of the Earth around the sun. And the reason for that is that, the Earth doesn't deviate from its orbit in any significant way for eons. So you can pretty much count on that. It's not perfect, but it's on the money pretty much. It goes around and around, always the same. Why? Because the Earth doesn't scrape its shoulder against space, because space is nothing. Unlike in relativity, where it's a little ball that's got this white stuff outside that nobody knows what it is, nobody wants to define. But space in rational science is nothing. And nothing is that which doesn't have shape. Thing, that which has shape. Nothing, that which doesn't have shape. See how easy it was? Anyways, the Earth cannot scrape its shoulder. No friction there between the skin of the Earth and space. And so it rolls around the Earth, around the sun, regularly. So that's the most accurate clock that we have in our region. Okay. Now, is it useful? Well, it's useful to determine what the year is. Okay, that's what it's useful for. And this fellow asked a question along those lines. He said, look, a gravity clock, meaning an hourglass, in a zero gravity environment is useless. Yeah, that wasn't the point. That wasn't the context. The context is if you take destruction of general relativity, which is another falsifying factor of general relativity. You take one, hourglass, okay, hourglass. You take it out there to the mountain, okay, and you leave one here at sea level, or you take one closer to outer space, not completely into outer space. You just take it farther out into the sky, and it falls at a different rate than the one on the ground. And it works in reverse to what general relativity says, what Einstein said. It works exactly in reverse. It works faster close to the source of gravity, and it works slower out there in space or farther up in the sky. And Einstein predicted, that's the word they use, prediction, said it's different. He came out with this law that says all clocks in the universe, work in the opposite direction. That the clock on the ground should work slower and the one in the sky should go faster. And that's not the case. Here you have a gravitational clock, which is what a hourglass is, a sand clock, right? And it works faster close to sea level and slower up on the mountain. We're done. It just kills relativity because relativity is based on that premise, on that supposedly, what is it, supposition, So if they start on the wrong foot, of course, the foundation of general relativity, this foundation is wrong. It's irrational. Okay, and here we have another issue. Fellow says body takes time to decompose, okay? And he says, the colony of microbes, I guess he's going over some biology stuff here, colony of microbes and worms feasting on it, the time this takes doesn't depend on temporal particles. It depends on the environment. Okay, I don't know what temporal particles are, I guess chronons, hitting them, right? Physical reactions, not time. Time is not a thing, it's a concept. Yeah, correct. But then he says, when time successfully changes the physical properties of objects, time changes the physical properties of objects. What is he talking about? He just said that time doesn't hit anything. There are no particles of time. Now he's talking about things, a thing called time that's hitting, the properties of objects, right? And the characteristics of a physical reaction. Then yes, time is a real physical thing. There is no speculation about it. The experiment is there. So this guy went around in circles. Can you learn anything from this fellow, this poor fellow? He says it's a concept, then he says it's an object. It's both. So you learn a lot with these people. They go around in circles and just say nonsense. That's all it is. Okay, fellow says, I think it's the same fellow, says, maybe not. Premise 1, science attempts to help people understand the universe. Premise 2, some people are bad at understanding things. Conclusion, science fails to explain the universe. No problems in logic I see here. Well, yeah, he's got it all wrong because science is not about understanding. That's where he's got it wrong. So here's the answer. Understand is on the receiving end. Someone can explain rationally, and the other guy is, Down's patient. He won't understand what this guy said. So understanding is not science. Explanation is science. Okay, so that's where his premises fail. Okay, so just keep that in mind. Here we have another fellow, and he says, the strange thing here is that you seem to be challenging the definition and purpose of science. Yeah, not of science, but of mathematical science. Okay, the religion of mathematics, that's different than science. That's what I'm challenging. And yet you end the video by agreeing with the current definition and purpose. I have no idea what this guy is talking about, what he understood. He probably didn't understand much. And here it is. The purpose of the current definition of science, in other words, mathematical physics, is to know, to believe, because that's what knowledge is. Knowledge is belief. Okay, I covered that the other day. Okay, I'm saying that knowledge, according to Plato, is justified true belief. When you know something, it's because you believe it. And if someone later on shows that you did not know it, that your knowledge was false, then does it retroactively convert to a belief? Is that what you had? So we have a problem. The word knowledge is a synonym of belief. There is no difference between knowledge and belief. And the purpose of genuine science is to explain objectively, in the case of physics, a mechanism. And how you concluded that the video ends accepting what it began attacking is beyond the rational mind. I have no idea what this poor fellow understood. But see, they don't clarify, because if they would clarify in detail, if he's going to take the trouble to explain in detail, then you would think that, then you would have something to address. You would say, okay, I understand what he was attacking or what he was referring to. But he just, blurts out a statement. I mean, if he's going to write, like he wrote a long piece there, he's going to write a lot, at least have the decency of putting exactly what you're referring to. But he just makes statements saying, well, you ended up concluding the same thing you started attacking. How did you conclude that? Give me an example. Tell me what's going through your tiny little brain. Okay? And I think it's the same fellow. He goes in there, he says, knowledge is belief, but belief has more than just one definition. Oh, it does. Okay, let's find out. It shouldn't have, because in science we only have one definition per word, right? But knowledge is not part of science, so it doesn't matter to us. So he says, a religious belief, for example, is one where you know something to be true despite complete lack of any supporting evidence. It is unjustified. A scientific belief is one where we are only able to come to conclusion based on the information we currently hold, one that may be supported by literally billions of pieces of evidence, and as more information is gathered, the belief alters, it is justified. All he did was repeat Plato. He said nothing new. Belief, according to Plato, was just unjustified belief, and knowledge is justified belief. Justified true belief. That's what it is. So all he said, he went through this whole thing when I had already stated all that, So no, there are no two definitions of knowledge, okay, or of belief. We have belief, which is unjustified belief, and knowledge, which is justified belief. And so here's my answer to justified belief. Okay, here it is. Okay, knowledge is justified opinion. Belief is unjustified opinion. And who cares if it is justified to you? Because again, what is your justification? Turns out that justification is also a belief. So I don't care about if your belief is justified or not. That the justification is also a belief. It's an opinion. And who determines justification? Doesn't a believer in God believe that his belief is justified, okay, or unjustified? So yeah, I mean, the justification itself is a belief, an opinion. So it doesn't matter. That's where Plato was wrong. That it doesn't matter if you're justified or unjustified. Absolutely doesn't matter at all. It's belief either way. So there is only one definition of knowledge and of belief, and that is that it's just a belief. Whether it's justified or not is also belief. Belief over belief. My belief is believable. That's all you said. And the final issue here, fellow talks about exists. He says something cannot exist unless it is explained. Now, any normal, reasonable person would laugh at you if you said that to them. Yeah, I agree. Fortunately, I don't say those things, but I don't know where he got this. Maybe watch another movie, I don't know. And yet you have said phrases that mean the very thing several times in your videos on gravity. Again, where did this guy, he concludes things and wants to put words in my mouth. I mean, if he would have put an example, that would have been great. That way I have something to challenge or to address. But just making a blank statement like that, why does he even take the trouble to write? You would think if he's going to take the trouble of writing something, at least put what you're referring to. I'll be glad to address it. I have nothing to address. He just put words in my mouth, said, oh, you said it. I said what? Okay, let me go with the question, see if anyone asked a rational question. You can see we had quite a bit of irrational people here. Okay, let's find out we have someone rational today. Okay, lots of comments here. One guy says, whose definition? Your own made up crap. I don't know if he answered me or someone else, but yeah, it doesn't matter whose definition it is. I don't care if it's mine or someone else's. Again, the definition is one that you step into the ring and defend. If you cannot defend your definition, well, then you have a problem, don't you? You can say, well, I believe in my definition anyway. So, yeah, okay, fine. You know, you can go with whatever definition, but don't come into science. In science, you got to defend your definition. And you can't say, I found it in the dictionary. so, so you found it in the dictionary. And the dictionary is never wrong. Okay? In fact, it's never right. If you find it in a diction, 99.9999999% of the time, it's wrong. It's not scientific. That's what I mean. You can't use those definitions in science because a scientific definition is one that you can use consistently. It's objective. Okay? If you can use it consistently, you don't have to worry about having a challenge to your definition. It's only people whose religion falls down the drain by the wayside, those are the ones that complain about definitions and they say, oh, you're doing semantics. Yeah, because your virgin was raped. That's why. Okay, another fellow says, let's see. Says, who is defining electrical as electron beads? What do you mean? Everybody defines it as electron beads. What is the photoelectric effect? Electron beads, being pushed by photon beads. So you have photon beads pushing electron beads out of their orbits. What is an electron? Is an electron a bead that rolls around the nucleus? If not, please draw your atom. So next time, illustrate your atom, or point to it somewhere on the internet. I'll be glad to address it. Just show me your atom with that electron. I want to see where you're going to put the electron, what you're going to illustrate. And, you can upload an image and, point to the URL, or if there's one on the internet that you know about, just point to the URL. I'll be glad to address it. Okay? So I need to see your electron before you talk about electron beads, but that is what the establishment has. In fact, the electric universe also goes with electron beads. Everybody uses beads. What do you see? Just look up a GIF or on YouTube how electricity flows. And what you'll see is little balls. That's how they illustrate it. Everybody illustrates it the same way. Electron beads moving along a wire. If you have a different version, be glad to hear it. Okay? Okay. Okay. In physics, an object is an identifiable collection of matter which may be constrained by an identifiable boundary and may move as a unit, blah, 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 blah. Okay, yeah, a boundary is known as shape, essentially, but, you have Euclid, and he said, he defined what a figure is, and he said that that's what has a boundary. And then in, what was it, definition 13, the one before it, says, what's a boundary? Well, a boundary is the cover of a figure. So he just went around in circles. So you got to define these terms. You got to know what a boundary is. Boundary of what? What is a boundary? Is the boundary of a square a boundary? Of a circle? Is that a boundary? Are we going to consider that a boundary as well? A perimeter or whatever? Okay, so yeah, we need to know what the word boundary means when you say that. But anyways, it says it's a collection of matter. It fails already there. A collection of anything is not an object. Collection is mereology. Collection of tables is not an object. Collection of atoms, gas. The gas as a whole is an object because it does have shape. But if you're going to define gas as a collection of atoms, then it's not an object. That's a definition. Okay. Objects we point to, concepts we define. Okay, so no. Okay. A field is an energy's interaction with materials. So a field is interaction. If a field is an interaction, then it's not a physical object. Okay, because if we're talking about an interaction, it's like saying, um, a boxer, and he punches the other boxer, and he says, "What's a punch?" Well, punch is an interaction. So there's no physical object called punch. Punch is the verb which interacted. One hand with the with, with the skin of the other guy's face. That's called an interaction. So interaction is not a physical object. You can't say that a field is a physical object, which is good. Yeah, field is an interaction. That's why field is not a physical object, not for the purposes of science. Okay, Phil says. Mass and weight are not the same measure in engineering, science, physics. Well, whether they're same measure in disciplines related to mathematics, we don't care. What we care about is, from the physics point of view, what is the difference between mass and weight? And the way we determine mass is by weighing it. So, and we end up with kilograms, which is the way we identify weight. And people say, well, that's in ordinary speech, not in science, not in physics, not in mathematical physics. Well, the question is, we've never been able to isolate mass from weight. Okay, mass, we would have to count atoms and express the result in terms of quantity of atoms. We do neither. We do not count atoms, and we do not express mass in number of units, in number of atoms, number of hydrogen atoms, for example. We do not express it that way. We always express it in terms of a measure, not in terms of counting. And measuring and counting are totally different. Counting, you count 1, 2, 3, 4, 5. And you would say, well, this thing has 1 trillion atoms. That would be the mass of that thing. That's not how we do it. We say it weighs 1 kilogram, which is a measure and which is the same as weight. We have no way of isolating mass from weight because we don't count atoms. So if you take whatever object, a piece of steel from the earth to the moon and weigh it there after you weighed it here, you say, well, they weigh differently. Yeah, and the mass of them is also differently because the way we determine mass is by weight. We put them on a scale or whatever and we weigh it. So no, we never express mass that I've seen. I've never seen anyone express mass in a quantity of atoms. I've never heard anyone say, look, a telephone weighs or has a mass of a gazillion atoms. Never heard that. Okay, let's see. We have zero volume is called vacuum. Yes, correctly. That's what a black hole is, zero volume. Okay. Give me a second here. Well, lots of comments, but no questions. Just debates among the listeners there primarily. It says squares are in your mind and are not an object. Well, you have to define object in order to know whether a square is an object or not. And if you define it as that which has shape, well, the square has shape and so does a cube. So you have to define the word object in order to find out whether a square is an object or not. You just follow the definition. And if you have a different definition of the word object than me, no problem. But then you got to defend it. You got to get inside the ring and fight for your definition. Okay, you can't just say, "Well, that's my definition." Okay, yeah, well, you can define anything you want, but you can't defend it because you're afraid for someone to tear it to pieces. That's the problem. And believe me, if you want to debate the word object, you came to the right person. I know what a thing is. In fact, I'm more proud of my definition of the word object and the fact that I discovered how important defining the word object is for the purposes of physics and science. I'm more proud of that than of my rope. I would put that on top. If I'm going to heaven, I'm going to heaven because of the word object, not because of the rope. Okay? Okay. Entanglement says the universe is connected. No entanglement. I don't know if he's saying no or yes, but no entanglement says the universe is connected. Don't know if he says yes or no. Okay. Okay, one fellow says a wave is an action verb. What's waving? Yeah, you have to identify the thing that's waving. Okay, and for that you need to define what a thing is. Hopefully, it's not that which you can see or touch because we can't see or touch the mediator of light or gravity or any of those. Space-time is a field and that is an object. Well, we just covered that. No, space-time, I don't know about space-time, but field is not an object. Okay, and if space-time is a field, then it's not an object either. There's a physics definition of time. Change or the interval that change occurs. Yeah, no, that's like I said, time is not change. It's a little more than change. Motion is change, but not time. Okay, they're not synonyms. And I covered that. Fellow says there something about shape, but I guess only he understands himself. Square is only in your mind. Yeah, it doesn't matter. Square, you can. I can draw it out here, so you can put a square out here as well. We call that a square. We point to it, and again, you don't even have to draw it. Like I said, you have a cube, right? And if I point it at you in the right way, you see only one face. Okay, assuming that we're a perfect cube, right? And I point it to you and say square. See how easy it is? It was square is the face of a cube. Okay, now is it a perfect one? No. It's a simulation of the ideal square, okay? But the point is that if you see a shape, if God, with all his powers, right? Because God is all powerful, remember. You don't like God, maybe you like the devil, okay, we'll do the devil. And he takes his magic wand and he goes abracadabra and puts a square in the middle of space. Okay? Because he's got the power. He's got the power to do that. So he puts a square in the middle of space. That's all he created. He's just starting out. He's starting out small. So he puts a square or a circle in the middle of space. Well, that's a square. It's got shape. And it's outside his mind. He put it out there in space for you to see. So he's got that power. He can put a square out there, okay? And you see it and you say, okay, that's a square. I mean, if now that we all know what a square is out there, you can close your eyes and visualize a square. And what are you going to visualize? What do you think you're seeing? When you close your eye, you see a square or a circle or a triangle. It's no biggie. So a square is just the side of a cube. That's what it is. And a circle is the perimeter of a sphere and so on down. Triangle, maybe the side of a pyramid. Of course, we're talking about ideal geometries, but God is all powerful. He can make a triangle in the middle of space. And that's how I would present it to you. I would put a triangle out there in the middle of space with space as the backdrop. You would see a shape. And I point to it and say, triangle. And the ET who's next to me, he learned the word triangle because he looks at that, he sees the triangle, he says, okay, that's a shape. That's an object. It's got shape. We're done. See how easy it was? Very easy, really. Okay. Anyways, we'll see you next time. What is it, on Sunday? We'll see you then. And we'll continue with this series of this fellow and find out other arguments, rejoinders that I'm going to be bringing up to counter his arguments. Okay. So we'll see you then. We'll see you on Sunday. Bye-bye.